What? What? What the fuck just happened? Did he just eat the fish? What? 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 One of astronomy's great enduring mysteries is what really happens on the inside of a black hole. We know that anything that gets too close to a black hole is ripped up and destroyed thanks to its immense tidal gravitational forces. But if you were able to jump right inside of one, towards its very heart, then what would happen and where would you end up? It is this spooky scientific question that has plagued scientists for more than 100 years, and thus it is going to be our topic today. Black holes are the most fascinating and mysterious objects in the universe. They are pockets of space and time which exist outside the laws of nature, and are places where time and space as we know it cease to exist. What really happens on the inside of one of these universal boundaries remains a mystery, but among the possible explanations, there is always an inescapable one, which can neither be proven nor ruled out. The idea that black holes are gateways to other parts of space, or maybe even to new universes entirely. Today we will aim to establish what truly lies on the other side of a black hole. To understand how a black hole could act as a gateway, you first have to understand the very nature of space and time. To date, nobody has understood this as well as Albert Einstein. According to his world-renowned and time-tested theory of general relativity, space and time are fundamentally linked, like two sides of a coin, combining to create a malleable cosmic fabric which lines the entire universe, known simply as space-time. And we liken it to fabric because it is warped by the matter upon it. The plane of space-time is curved by the presence of mass. Mass is a form of condensed energy, and where there is condensed energy, space-time will fold around it, and the resulting effect is felt as gravity. The heavier and more concentrated the mass, the more the space-time surrounding it will warp, and as such, if we compress enough mass within a sufficiently minuscule volume, then space-time will deform so much that an abyssal, never-ending sinkhole will be created in the fabric. Within this area of warped space-time, the gravitational influence is so great that space-time itself starts flowing into the anomaly, carrying everything with it, including light. This results in a dark sphere around the area where light is being dragged into the gravitational well, known as an event horizon, and thus we have a black hole. At the centre of every black hole lies a space-time singularity, a point so deformed by mass compression that it punches through the fabric to become a physical boundary of the universe. A place where all light and matter meet their eternal end. In addition, a black hole also has a curvature singularity, which is the part where the curvature of deformed space-time begins to take on infinite values. It is here where nature begins to depart from general relativity and all our other models. If we were somehow able to survive up until this point, then we would experience something very strange. Space and time, as connected entities, would switch roles, as the black hole's interior becomes infinite. The singularity is suddenly no longer a physical point, but rather an inevitable event in the future. Space is so warped that all paths will inevitably lead us to this singularity. But time is so warped that we would require an ever-increasing amount of it to get there, as time on the outside slows down and eventually stops forever. And so, at this point, our cosmic fate would be sealed. We would be frozen in that moment of time forevermore. The singularity now represents the infinite future of a featureless, timeless dimension from which nothing will ever be able to escape. You would never reach the bottom of the sinkhole. You would just continue cruising deeper and deeper into your eternal cosmic chamber. Unless you were to hit another part of space-time. We don't know what the implications of curving space-time to infinity really are, and so perhaps it is possible to curve space-time all the way round, so to speak, so that a black hole may end up leading to a completely different part of space. You would then have a link between the two disparate regions which pinches them together, ignoring the cosmic distance between the two, akin to folding a piece of paper to connect two dots, as opposed to drawing a line between them. You would have an Einstein-Rosen bridge, better known as a wormhole, a means for a black hole to subvert the space-time continuum by acting as a portal. Wormholes are a fascinating prospect, and perhaps not just one of science fiction. While they've never been observed in practice, they are consistent with general relativity, and some scientists believe that they may be possible. If not through black holes, then through cosmic strings from the earliest nanoseconds of time. But don't get too excited, because even if wormholes are possible, they almost certainly wouldn't be practical. Even if a wormhole bridge could form inside a black hole, it would be incredibly unstable. The immense gravity on the black hole's interior would constantly stretch and contract the space-time bridge, before eventually severing the connection into two regular black holes, perhaps only seconds after it formed. Furthermore, even if a wormhole could remain connected for longer, it still wouldn't be a practical means for universal travel, as all the points made about time stopping within a black hole still stand. You would never be able to reach whatever lies on the other side of the wormhole. You would simply get stuck somewhere in the middle and age to death in the process. But make no mistake, just because a wormhole isn't suitable for traversing, that doesn't mean that two parts of space and time can't be pinched together for however long. It is not known what kind of black hole, if any, could create such a bridge. Perhaps not your standard run-of-the-mill collapsed star, as if that were sending its relatively limited mass into another part of space, it probably wouldn't survive for very long. But maybe supermassive black holes, which lie at the hearts of large galaxies and can be billions of times heavier than the Sun, could become so massive that they are somehow able to burst through into another part of space. We have no idea what such a bursting black hole would look like at the other end, but in any case, we call it a white hole. As the name suggests, a white hole is the opposite